Alright, so in this video I'm going to talk about the hyperbola and the parabola. Okay, for the hyperbola, again we have foci for the hyperbola. And the difference is that this distance, the distance from one of the focus points to a point on the hyperbola, minus the distance of the point to the other focus is going to be equal to a constant. So this is what we're going to be looking at today. Now the big difference here is that in the ellipse we had c squared equals a squared minus b squared. Here for the hyperbola you have b squared equals c squared minus a squared, which when rewritten is c squared equals a squared plus b squared. Your k is still 2a. So instead of going through all of the removing of the square roots, I went ahead and went straight to what we get once we do remove the square roots, which is k to the fourth plus 16c squared x squared equals 4k squared x squared plus 4k squared c squared plus 4k squared y squared. And then I substituted in 2a for k and a squared plus b squared for c squared. Went through all of the mathematics, and you notice that 16a to the fourth and 16a squared x squared cancel out. The remaining terms, 16b squared x squared, 16a squared b squared, 16a squared y squared, all had 16s in them. So I just divided them all by 16, leaving me with b squared x squared equals a squared b squared plus a squared y squared. Now we needed to bring our a squared y squared over to the other side, and then this needed to be 1. So once I moved my a squared y squared over, I divided everything by a squared b squared and ended up with x squared over a squared minus y squared over b squared equals 1. The important thing with the hyperbola is determining which way it opens. Does it open left-right, horizontally, or up-down, vertically? And that's going to be dependent on which of the terms is subtracted. If the y squared is subtracted, it opens left-right. If the x squared is subtracted, it opens up-down. So now what you need to complete is the exploration questions on page 6C. Okay, now we're going to finish up with the parabola. What I need you to understand is the distance from the focus to the vertex is the same distance from the vertex to what's called the directrix. The directrix is a line that if we have a parabola opening up or down, it's going to be horizontal. If we have a parabola that opens left and right, it's going to be vertical. And the reason why this is important is that it allows me to find the coordinates of this point L, which is directly below the random point on the parabola. And for the parabolas, the distance from the focus to any point on the parabola is equal to the distance from that point to the directrix. Okay? So number one, they're just simply organizing the graph. And then we come down here to the rest of the exploration. What are the coordinates for P? Well, they're x, y. Then we find the distance to find the length of FP. Now this is the distance formula. Plugging in the values for our diagram, you get the square root of x squared plus the quantity y minus c squared. Then the distance formula to find PL is the square root of y plus c quantity squared. So here we set them equal to each other, which makes it a little bit easier because you just have to square both sides. So I squared both sides here, expanded these binomials, canceled out common terms, kept my x squared on the left, and moved my 2ycy over to the right. So this is your standard form for a parabola. Or you could write it this way. This 4c represents the coefficient in front of your y term. Or if the parabola turns left and right, it is the coefficient in front of your x term. Okay? So now your task is to complete the exploration questions on page 6D. The homework has been posted as well as the quiz for 2-3. Homework for Hyperbola and Parabola is due next Wednesday by 3 o'clock, and quiz 2.3 is due before midnight next Wednesday. If you have any questions, come see me.